So we're going to talk about 4.1c mathematical modeling, and we're specifically going to look over at, I think it's page 5, where we first start talking about this BMX bike, and actually scratch that. This is actually page 6. So part 3, I'm going to skip right to this, and this will explain the rest of the stuff that you need to know for the worksheet. First off, it gives you a chart, and it's comparing bike mass to the minimum jump height. I'm going to kind of cheat and copy this. Open up an Excel spreadsheet and go and type in all the numbers that you see there. And I actually need to move mine. So if you have everything highlighted, you can click. Once you have the little move arrows that look like that, you can click and drag and move this out of the way. And we need some labels for these two graphs. One's for bike mass, the other one's for minimum jump height. So let's type in bike mass and min jump. Okay, good enough for government work. Let's highlight these and say insert, scatter, scatter. And now we have a scatter chart. Now, this is something you have not made with me before in class, so let's talk about how we can format this. Once we go to layout, we have all kinds of different options. We have chart title. If we click on this, I'll probably want a title above the chart, and I'm going to put in see, you have to click a few times. BMX jump heights. Okay. We have axis titles. Let's do a horizontal title below. And this is going to be, what is this? The bike mass, and that would be in pounds. I'm having a hard time getting this all to select. That's okay. Here we go. Bike mass pounds. LBS. Cool. We want the y-axis, vertical axis, rotated. And if we triple click on this, we can type in minimum jump height, and this is in, what is this in? Inches. Okay, so now our graphs have labels, we have units, we have a title. This series 1 thing doesn't make a whole lot of sense, but that's okay, we can leave that there. So we have all of this. Let's go and look at our grid lines. For horizontal grid lines, let's show major and minor. And then for the vertical grid lines, let's show just the major ones. Alright, so now it's a little easier to see things. And something else that's going to help anytime we have a scatter plot graph is to have a trend line. Go ahead and click trend line and scroll all the way down to where it says more trend line options. Here we're going to have a linear trend line. We are not going to have an intercept through 0, 0, but we are going to display the equation on the chart and predict backward. I don't know if we need to predict any forward. Well, let's predict forward some. Let's go forward like 20 and see what that looks like. Let's close this out. Ooh, things got all jumbled up. Oh, that's our equation. Alright, that little equation, click and drag that up there. We still have this selected. Now let's predict backwards too. So our last point, if I went and make this a little bit bigger so you guys can see it. Oop. This point is at 19, so we're going to predict backwards 19 as well. So let's go back into layout, trend line, more options, and predict backward 19. Okay, so now we can see more of what's going on with the graph. And wow, this forward one may have went too far forward by just a little bit. You can tell it crosses the x-axis somewhere in here. This is an important part. This is an equation that we are going to be using. Copy that. Let's take a look back at your worksheet. So here we just put in all the data and said to create a scatter plot, which we did. Find the trend line. We did that. Print a copy of your worksheet that includes the following. Make sure you print this. I need a table of your data. That's this thing. Scatter plot with formatted axes, axis labels, and units, and an appropriate chart title. We did all of that. Trend line and its equation displayed on the scatter plot, and we did that as well. I just copied the trend line, or the equation for it. So it says write the equation relating bike mass to minimum jump height in function notation. So define your variable. This was the original equation. Oop, let's not put the C in there. That's kind of weird. I just copied this off the graph. This comes from right here. And that's when you say trend line and you go down to more options and you checked off this display equation on chart. The equation for your trend line is the important part that it's looking for here. Okay, but it doesn't want X and Y. What it wants is function notation. So this is actually going to be J of W. This is the jump as it's related to weight. And here it's going to be whatever number this is times the weight. Okay, but we need to define our variables. So we're going to put down below this J of W is going to be the jump height, and just plain old W is going to equal the weight. The domain of the function is anything that makes sense for the X value. So let's take a look at it. X is going to be greater than or equal to 0, but it's going to be less than or equal to something over here. And we can figure that out by finding what the x-intercept is. You find the x-intercept by plugging in 0 for y. So if y was 0, then 155.38 would equal negative 155.38 is equal to negative 3.789x. So we just divide the two. So I'll just say this is equal to 155.38 divided by 3.7891. Okay, that comes up to be 41.0071. So let's see here. And there's not an easy way that I have to do a greater than or equal to, less than or equal to. So just assume there's another line under here. Oop, it didn't like that. Let's tab that back over. I'll make it red for you. That way you know this is an answer. Just know these should have an equal sign under each of these. Okay, so these are all the x values that make sense. As long as it's between these two numbers, x is a good number. And actually by x, we mean w. The weight is going to be between 0 and 41. Anything over 41.0071, the bike is not going to get any air at all off the ramp. Range of the function, this is dealing with how high this bike can actually jump. And it's going to go anywhere from 0, and here's our J of W. Again, this is supposed to be, it's going to be greater than 0, and it's going to be less than whatever our y-intercept was. Well, I can see that from here. If we plugged in 0 for W, our y-intercept would be 155.88. Or I'm sorry, 38. Cool. So then, is the slope of the line, what is the slope of the line, positive or negative, and explain the interpretation of the slope in words. The slope in this case is negative 3.7891. M is the universal symbol for slope. And it means as the mass increases, the jump height decreases. Okay, if an engineer designed a bike that weighs 18 pounds, predict the minimum jump height. All right, well, our equation's here. So let's put down our equation. And we're going to plug in for W 18. So our jump height, J of W, actually in this case, function notation, it's going to be J of 18 is equal to negative 3.7891 times 18 plus 155.38. Alright, and what is that? Well, I'm going to go over to I'm going to use Excel as my calculator, and I'm going to say over here equals that it's negative 68.2038 for multiplying those two together. So now I have J of 18 is equal to a negative 68.2038 155.38, and that would leave our final answer $155.38 plus that equals 87.1762. Awesome sauce. Let's just make this all red. Cool. Same kind of thing. In this case, it wants to know, here's our equation. If our bike only weighed 1 pound, so we're plugging in 1 for the weight. And what would this be? Well, it's going to be 155.38 minus this number. Alright, so if the bike only weighed 1 pound, supposedly, our jump height would equal, what is that, 155.38 minus this. Let's see here, equals 155.38 minus that, 151. Whoa. Here, make sure I paste this into the right spot. It would equal 151.5909. So you're saying if you had a 1 pound bike, it would jump up this high into the air. Is that a good predicted height for a 1 pound bike? Does that make sense? It shouldn't. That you just go off the end of a ramp and pop up that high into the air. Explain that in words. And then if the minimum height, and here again we're using the exact same equation, we're just plugging in something different. So